Let's take a look at our fifth example. In this case, we are using a quotient, so we will be using the quotient rule. I'm even going to write that out for you. Okay, so what is the quotient rule? Well, remember, it's f prime g minus fg prime over g squared. Okay, so we can go ahead and label our top function f and our bottom function, let's do orange this time, g. All right, so here's our f function, here's our g function, and we will be taking the derivative of each of those. We know this is implicit because we have a y squared term within this function, and we're taking d dx of that. And so anytime there's a y and you're taking the derivative with respect to x, that's implicit. Now, I did want to point out, I've been thinking about this, if you just did d dy, and again, I talked about this in the intro video, you might want to know the change in with respect to y instead of x for various reasons. And let's say you just did d dy of y squared, well, you wouldn't need implicit for that. It would just be 2y because the derivative that you're taking with respect to is the same as your variable. Okay, so just wanted to point that out before we moved on. So now that we've established that, let's go ahead and move on. All right, so we have f over g basically, and we're going to be using the quotient rule like I just mentioned. What we want to do is figure out what f prime is, right? F prime we need and g prime we need. So we need to take the derivative of natural log of xy squared, which was the numerator of our fraction. So what is that? Okay, well, this is where it gets a little complicated, but that's okay. We are using the chain rule in combination with implicit, which is actually kind of like a chain rule. So it's like a chain rule within a chain rule. First of all, we know, let me try to break this down for you as best as possible. We know that the derivative of natural log of x, okay, is 1 over x, right? So let's just start with that simple fact. So the derivative of this would be 1 over xy squared without doing any chain rule, right? Then we'd have to multiply by the derivative of the inside, right, in order to use the chain rule. So it'd be times the derivative of the inside, and we're going to go from there. All right, so that's pretty much all we need to explain for right now. So now we need to focus on what is the derivative of xy squared. Well, we're going to use the product rule to figure that out. So again, derivative of natural log of xy squared is 1 over xy squared times the derivative of the inside. To do that, we will use the product rule. So it will be, again, f prime g plus fg prime. Let's use some different colors here. So within our parentheses, this will be our f, the x. Sometimes it's hard for me to write. There's our f, and there's our g. Maybe I should do the bottom here. There we go. Okay. So here's our f prime, which is just derivative of x is 1, right? G, which is y squared. So f prime g plus f, which is x. And then our g prime. So what is the derivative of y squared? Well, it's 2y times dy dx. See how much it helps just to break this down? It's a chain rule, it's a product rule, it's a implicit differentiation, but you're just doing it one step at a time. Okay, so let's keep going after this. Basically what we did in this step was we just converted the derivative of that to all of that, and then we're just going to simplify that. All right, so this will, simplify in second, become y squared plus 2xy dy dx. But this is just our f prime, right? Remember, this is the entire quotient. So we need to figure out d prime in order to use the quotient rule. All right, so g prime, remember, a g function is tangent of x. The derivative of tangent is secant squared, right? So now we can rewrite the quotient rule, and we figured out every single component to this. We figured out that f prime was all of this, okay? So I will even label this for you guys so you don't get confused. All of this right here is f prime, okay? Then next we have g, okay? I have to clear this when I move over. Minus f g prime. All right? All over what? All over g squared. Okay. So then, once you break it down that way, then you just plug all that stuff in and you simplify. Now I do want to one more time. I'm going to go back and show you what we've just done because I know it can be really overwhelming. And this is, of course, by far the most involved problem we've done. We have a quotient rule on the outside layer, I guess you could say. Within the top part of the quotient, we have a chain rule. Inside the chain rule, we have a product rule, which involves implicit differentiation. So quotient rule, chain rule, product rule, and implicit, all in one problem. And we also have derivative of a transcendental function, natural log, and derivative of a trig function. So anyway, we did all that, we got to this, and pretty much from there all you have to do is simplify. So as I said, this will become y squared, this will be plus 2xy dy dx, and all of that will actually go on the top of this fraction. You can put all of that over xy squared, multiply that by tan x, minus natural log of xy squared times secant squared x over tan squared x. Okay, so here's kind of the semi-simplified version of this up here, and this kind of leads us to something that I want to talk about and then, coming up, which is how we can get dy dx by itself once we take the derivative of something. It's pretty interesting, and it occurs when you have an equation, of course. Right now we're just taking the derivatives of expressions. So that's just about as hard as it's going to get for the sake of this class. Lots of stuff going on there. Quotient rule, chain rule, implicit, product rule even. If you have any questions about this, let me know.